Okay, here we are. Okay. So this right here, you don't have to write this down. It's just FYI for your information if you ever want to know what that means. This is just the history of it, because I've had students to say, where does this all come from? Well, it was a helpful technique in picturing set relationships. This was named after an English mathematician there, John Venn. He invented these to use to illustrate ideals in his symbolic logic. In a Venn diagram, a triangle around the set represent the universe set, and the subsets were represented by circles. So you label circle A, when you have it, you have a circle A, and you label A, and so on. If you have B, you label B and C. Okay. Okay, now you do need to draw this, because you'll be seeing this when it goes to when you're doing your Venn diagrams on your Alex. So there's like 4 different cases here on the Venn diagrams. You may have a case where the sets A and B have nothing in common, so that's called disjoint. Then you may have something, in this case, where everything of A is in B. And then you have a case 3 where everything of A is the same as everything in B. Remember us talking about the equal sets? So everything in A equals to everything in B. Then also you may have one that's also the overlapping sets, where you have set A and set B, and they will have some in common and some not. Then you may have some that doesn't belong to either one, and that goes in the universe. Questions? Okay, I'll give you guys a minute to write that down. Someone still need a minute to write down all these pictures? Okay. And also it helps if you have different color, like a pencil or pen. If you happen to have color pencils, that would be good.
Color depends on the color.
That's when I did like A in blue and the B one in red. So I'm showing that there's 2 different sets. Also, anytime you guys ever want to take a picture of this stuff, follow me. I think it's best to just write it down. I need another minute. Okay. Okay, I'm going to go to the next slide. Okay, right here is some definitions. You may want to write this down. So with the definition, we have a complement. Complement of set A is represented as, and as you see here, that's A, it looks like an apostrophe. Okay? So that's the complement of A. It is the set of all the elements in the universe set that is not in set A. So let's say, in this example right here, we have the universe is 1, 2, 3, 4, 5, 6, 7, 8, and we have set A, and it is 1, 3, and 4. So we need to find the complement of A. The complement of A, as it said here, is all the elements in the universe is not in A. So you look at the universe, and you compare it to A, and you pick out everything that's in the universe that's not in A. So we already have 1, so you don't count it. So we put down 2. 3's already in there, 4's already in there, so you have 5, 6, 7, and 8. The next thing is we have the intersection. The intersection of set A and B as symbolized, and yes, that looks like I think it looks like a horseshoe. It's kind of an upside down U. And it is a set that contains all the elements that are common in both set A and set B. Then we also have the union. Let me go over here so you guys can still write. So we have the union of set A and B is symbolized as, looks like A union B is a set containing all the elements that are members of set A or set B or both sets.
Okay, so if I'm understanding it right, the intersection is both.
The intersection is what they have in common.
Ah,
Common intersection. But union, let's say, you know, like you go to a family reunion, you got your dad's side, you got your mom's side.
right.
But as you put it together, that's still,
Oh, I see.
So
Yeah.
the intersection symbol is up or down,
the intersection symbol is upside down.
so it's.
So also, like, you think about an intersection, like if you're going, you know, you go to a red light and there's an intersection, that's where they cross, right? That's where they have in common, is right where they meet. That's the reason you have to stop, because sometimes the lights will let that will go while you're trying to go that way. And with the union, it's like I said, the mom and dad, that will be a family reunion.
Right.
Because you're bringing them together. It's a union. Yeah.
Okay.
And see, like you know, you would be pretty much the intersection of mom and dad.
Right.
That's what they have in common, is you. Does that make sense?
Yeah. Yes.
Okay, also, once you make note to self, you'll be using this later on. In sets, the word or is going to mean union, and the word and is going to mean intersection. I'm sorry if it's kind of small, but I try to put a lot into one slide. Questions? You'll understand it more because we're going to do more examples. Did you notice the other day I did lots of examples? So anybody need another minute to write this down?
2 seconds.
Okay.
I need a hundred as well.
You're going to start, Miss Jackson, so I like to just fly with it. Anyone need a, okay. Also, in your Alex homework, you should be caught up to where you're doing intersections and complements and unions.
That's actually where I was stuck, so.
So, yeah. Well, hopefully I've cleared up today. Because a lot of, when you try to read the explanation, you're like, what? What does this mean?
Right.
So I'll explain it. I think a lot of times I explain it better than Alex does. Then sometimes I use exactly what Alex says, and then I still explain it. Okay, everybody got that?
Almost.
Okay. But I do believe that once you have my lecture and then you do Alex, it just goes smoothly, don't you think?
Oh, I know that.
Yeah. Okay. Can we go on? You almost got it? Jacob?
Almost.
So we talked about complement. Like a complement. We talked about the union. Yeah, that's about right. U. We talked about intersection. Okay. Let me go to the next slide. Okay, the first thing we're going to do, we're going to talk about what it means to be a complement. So in this example right here, you can see this right here means universe, the universe. So we're talking about the set 1, 2, 3, 4, 5, 6, 7, 8. We have a set A, and it is 1, 3, 4. So let's find what is a complement. So the way to find a complement, it will be equal. You write your squiggles or bracket. Guys, I know it's not perfect, but you guys know what I mean. So we're going to write everything in the universe that's not an A. So let's see. 1's there. We don't write it down. So we have a 2, comma. 3's there. 4's there. So we write 5, 6, 7, 8. You gotta see that. So that is, you have A, and then you have a complement. Okay, everybody got that, right? Okay, now we're going to do some intersection of sets. So anytime we talk about the intersection, so we have the universe, this is what, 1 through 10, as you can see. Then we have A, and we have set B, and we have set C. So let's look at here as we find what is the intersection of A intersect B. So you look at A and B, you put equal the squiggle. So what does A and B have in common? So let's look. It has a 1, right? Write it down one time. Does it have a 2? No. But it has a 3, right? 3, comma. Does it have a 6? No. A 7? No. An 8. Well, that's the answer. 1, 3, 8. Now see, I did that, is I compared A and B and I asked, what do they have in common? Let's go down here to B. B says A intersects C. So now we're looking at these two. What does A and C have in common? The empty set. Remember, the empty set is in all sets. So we're going to look at C here. Now, C is A complement intersect B. Now, before I can find out this, I must first find out a complement, right? What what is a complement? So over here, I'm gonna write a complement. Looking at A in the universe, what does the universe have that what does the universe have that's not in A?
4,
A 4, wait, 4, 5,
6,
a 6,
7, 9, and 10.
10. But that still didn't answer this. Now looking at this and B, what do these two have in common? These two.
6 and 7.
6 and 7, right? That's all I see. 6 and 7. You guys see how I did that? I broke it down. Now, if you get so good to where you can go, just looking at, you can know in your mind what a complement is, and you intersect with B, and you come up with this, that's awesome. But I have to write everything down. I take it one step at a time. Okay. Looking at D, we have parentheses. We need to find out the complement of A intersect B. Well, we just happen to have, right? We have that. We have A intersect B. So what is in the universe that's not in A intersect B?
2,
Okay. 2, comma,
4,
2, 4,
5,
5,
6,
okay,
7, 9,
9, and
10.
10. Squiggle. You guys see that's, you guys see how I got the answer?
Can you redo that one again? Like another example of ours one?
Do a different one like that?
Yeah.
Well, how about if we have, let's find, we'll use the same example, let's find, I'm sorry about my F's. I feel like I'm getting ready to be cursive. So the other one said, what is that? I said, that's an F. Then I thought, oh yeah, F goes, yeah. Anyways, you guys know what I mean. So anyways, let's find out what let's have a D here. Let's make D the even ones. 2, 4, 6, 8, 10. Okay? Let's find what A intersect D complement. Right? What's my first step? First of all, I have to find out what does it have, what is A intersect D, right? Before I can find out the complement of it. So underneath here, A intersect D. What does, looking at A and looking at D, what do they have in common?
2.
2 and 8, right? Sometimes it helps if you point to them. Okay, we're doing this, so I have to look at these two. I have to point to them. In my mind, I'm like, what? I think sometimes I have ADD because sometimes I have to focus on that. Because I'm like, I'm in a place like, what? Where are we at? Okay, now we're going to find the complement. So with this, we look at the universe and you ask yourself, what's in the universe that's not in A intersect D? So go ahead and tell me.
1, 3, 4,
1, okay, don't go so fast. 1, 3, 4,
5,
5,
6,
6,
7,
7,
9,
9,
10.
10. You see, I got that. But I did have to do an extra step. So as you see here, do you guys remember order operation? You must first do, what's the first thing?
Is that
Parentheses, yes.
PEMDAS.
PEMDAS, yes. So you must do your parentheses before you can do the complement. Then if there's more to it, and yes, I'm gonna let you know, Alex will put like union C in there or something. Then after you do this, then you put C with it. Take it one step at a time. Okay, now we're going to do some union. Here's some, really? Okay. Let me erase this so I don't confuse you guys and say, what is she doing? Okay, that's much better.
Yes, it is.
Okay, now we got this example. So let's find, as you see here, I'm going to find A union B. Remember, union is in A, B, or both. So you just put it together, okay? So looking at A and B, if it helps, point to it. So let's put them together. So even though you see a 1, 1, you put 1 down one time. You don't go 1, 1, because Alice will be like, that was wrong. So it's 1, comma, I see a 2, 3. You must also put it in order or he will count you wrong, Alex will. Shouldn't call it, I should say the program will count it wrong. So 1, 2, 3, 1, 2, 3, 6, 7, 7, and 9. You see, I got that. I put it together. The next thing is we're going to do A union C. A union C. So we're looking at A and C. A and C. Right there. So let's put those together. So let's put it in order. So we got, what have we got? 1, 2, 4, 5, 6, and 9. Is that right? 4, 5, 6, 9. Yes. Sometimes you have to write it on your paper, and then you figure it out, then you type it in Alex. Or you might have to look at my notes, then you write down, then you do it in Alex. Okay, looking at C part here, we have A complement union to B. Now before I figure this out, what do I need to do? What do I need to find first? Complement, yes. So let's find out over here. I'm gonna write. Why do I put it there? Is because I'm looking at A and I'm gonna look at the universe, right? So what is in the universe that's not in A? So go ahead and tell me.
3,
3, 5, 7, 8, 9, 10, right? Now down to this problem, we got A complement union to B. So we're looking at these two, and we're just going to put it, since it's union, you put it together. So that's 1, 3, 1, 3, 5,
6,
6,
7,
7, 8,
9,
9,
10.
10.
I have a question.
Yes.
So, well, it's the universe of, not the universe, the complement of A, even though the complement of A excludes 1 because 1 was in the set of A, we still put 1 because it's in the set of B? It's
Yes.
not, okay.
Yes. That's when it comes back.
Okay.
That is a good question. That's when you see 1 again is because it was in B. It brought it back in. You had Miss Jackson thinking there. So, okay. Looking at D, we have the complement of A union B. Well, it just happened that we have A union B. Do you see A union B? We have it here. So we don't have to write it down again. So this time we're going to compare this to the universe because we're doing a complement. So tell me everything that's in the universe that's not in A union B.
5,
Wait. 5. What else you got?
8.
8,
Uh-huh.
10.
Is that it? 10, yes. Did that help? Everybody need another minute to write this down? You got it, okay. I'm gonna erase it because it'll mess up my next slide. Here we go with the and or. Remember I made you make a note of it? The word and is the intersection and the word or is the union. So in example 1 here we have A is 1, 2, 3, 5, 6, 8 and B is 1, 3, 4, 7, 9, 10. So let's find out what and is. Remember and is intersection, right? So I'm talking about A intersect B. So, the intersection means what they have in common, yes. I was hoping you guys were feeling the blank there. So what does A and B have in common? A 1, a 3. It looks like that's about it. That's it. Now sometimes I'll also show people, if it helps, I would say, okay, we've got the 1 in common, we've got the 3 in common. This will be on your paper, you know, yeah. You remember having to do that, like when you did the least common multiples, you had to, you remember having to do that? Okay.
Yeah.
But it, okay. So, or, what does or mean? The union. So that means A union B. So union means you put it
All together.
together, yes. So what is A union B? Make sure you put it in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Questions over what does it mean to be a complement? What does it mean to be a union? Intersection. I'm going to go and do another section here. You got, who needs another minute? Write this down. Okay. Okay. I'm going to go on to the next one here. Okay. I'm going to erase this. Next thing we're going to talk about is we're going to talk about Venn diagrams. Venn diagrams. We are going to be constructing a 2 Venn diagrams and a 3 Venn diagram. 12, 15, okay. Okay. And I hope you can read my little writing. Yes, this says Pepsi, and yes, this says Diet Pepsi. But you know, when you're on the computer, when you do it yourself, it doesn't look so pretty. So that's the reason a lot of my typing looks much better. Okay, so let's suppose here that we had 200 students that were surveyed about soft drinks. There were 90 students who said they liked regular Pepsi, 75 said they liked Diet Pepsi, and 13 who liked both. So fill in the Venn diagram. So, by the way, I should have done this, but I didn't. But anyways, you're always supposed to have a rectangle around your Venn diagram, okay? Because the outside here is going to be your universe, okay? So let's read this. Now, sometimes you have to, when you're reading these problems, sometimes you have to take it backwards, you see. So let's look at here. So there's 200 surveyed, okay? There's 90 students said they like regular Pepsi, 75 said they like Diet Pepsi, and 13 like both. So let's start from the bottom. 13 like both. What they have in common, by the way, this is your intersection. This is the intersection of Pepsi and Diet Pepsi. Intersection, that's where they overlap. So if 13 like both, we're gonna put a big 13 here. Okay? And also, it's good to have your calculator. I think I told you guys to get one. If you have it, go ahead and get it out. Always carry it with you when you come to 121 math. Okay, so 75 like to drink Diet Pepsi. Now to figure out that, you must take 75 minus the 13, and that's 62. It was Diet. Yeah, Diet. 62 goes here. Then we go on up, and there were 90 ones who said they liked regular Pepsi, which is this side, right? So I'm going to take the 90 minus the 13, and you get 77. Now, but there were 200 that were surveyed, so to find out what's in the universe, there could be people out there at the college who doesn't like to drink Pepsi or Diet Pepsi. Like me, I like tea or flavored water, which is not Pepsi or Diet Pepsi. So what you do is you take your 200, minus, and we're going to add those together, 77 plus 13 plus 62. So minus the 77 plus 13 plus 62. Or you can add these, then subtract off the 200, and that should give you, and you put it down here, 48. So there's 48 students who didn't drink Pepsi or Diet Pepsi or both. Does that make sense? This is one of the applications that you use in the Venn diagrams with a 2 Venn diagram, which is easier. And you will be doing this on Alex. That's when a lot of people want to use exactly the numbers they give you. That's not the key. The key to go is to go from bottom, go up. Yeah, you read it going down, but then when you work the problem, you go from the bottom going up. I bet you're like, what? That's the way it works. When you do it like this, you'll get it right every time. Questions?
So with the Venn diagram, we don't put the 90 or the 75. The only
No.
one from the problem we use is the intersection.
The intersection, yes. Yes.
Okay.
And you're always subtracting. You see I got the 62?
Mm-hmm.
From here, I put the 13 there, right? Because this is the right both. That's the intersection. 75 liked the Diet Pepsi. So I took 75 minus the 13, and I got 62. And then the 90 who liked a regular Pepsi, which is this, so I took the 90 minus the 13 and got 77. Okay, then I said, there could be some who doesn't like any. So then I had to take the 200, but I had to figure out what this is first. Then you take it off the 200 and I get 48. And usually on your Alex, you do this, then you answer these questions over here on the side. I don't know if you guys got that far yet. And then you're over here going, it'll say, so how many students didn't like neither Pepsi nor Diet Pepsi? What would you say? 48. How many like both?
13.
13. Or how many only like Pepsi?
77.
77. You gotta watch how it's worded, okay? Now if it just says how many likes Pepsi, then you add these two together. But if it says only Pepsi, only, you put 77. Does that make sense? You have to watch how it's worded. Because then you'll be like, but Miss Jackson said I was just supposed to put 77. Ugh, I'm so frustrated.
Yes, I do have that problem.
Okay, so let me erase these. Okay. Let's go to the next problem. Okay, here. Now sometimes, on Alex, and you will have this problem, you'll have some that's, you'll have to figure out what this is. They give you this. And you're like, oh my goodness. So, looking at this, tell me what the universe is. So you had to put it in order. Go ahead and tell me. 1, 2,
3,
3,
4,
4,
5,
5, 6, 7,
8,
8,
and 9.
9. You see, I got that, right? I just looked
Versus all of them.
all of them, yes. It's everything, like I said in the definition, the universe set is everything in the discussion. So this is the discussion. Looking at A, what is in A? Put them in order.
7, 2,
2,
6.
6, and 7.
All right.
Right, you see that? This is A. And see, if you see it, I see it, put it in blue. Let's look at B. Give me in roster form, what is in B in order?
1,
Mm-hmm.
2,
Yes.
5,
Yep.
6.
6,
8.
8. Okay, now we're going to find out what A complement is. Well, since we already found out what A is, we just look at
No, he isn't.
what's in the universe that's not in A. Have you noticed that I'm using the definitions like I said? So what is in A complement? 1, 3, 4, 5, 8,
8, and 9.
9. What was it?
They couldn't see the board there.
Oh, okay.
I thought the 7 was the school.
Well, that's my handwriting, so I apologize about that.
No.
Now let's look at B complement. Well, we know what B is. We can look here or we can look over here. You know, if you're looking at the Venn diagram, I'm going to show you something, okay? Looking at the Venn diagram, let's find out what B complement is. I cover up everything in B. I cover up all this. And what do you got left? You got 7 and 3 and 9. Right?
And 4.
And the 4, right? This really 4 is supposed to be down here, but okay. So just by looking at it, you can tell what a complement is, right? So it is 3, 4, 9. Just like if I wanted to do
7.
7.
and what?
And 7.
7.
And 7, yeah. Come on. You know, I should start giving you guys points for catching me there. Yeah. Now also you can do that, for, let's say we want to look at just the Venn diagram. What is A complement? So I cover up everything with A. What do you got left? That stuff, right? You got, looks like you have a 1, 3, 4, 5, 8, 9. Yep, see? So sometimes you can just do that and go, okay, get it done. What was the Larry King there? And I said, get her done. That's right, get her done. Boom. Okay.
Forgot to erase it.
What now?
You forgot to erase it.
Oh, no wonder we're crazy. I went, what? Do I even have a picture here? Let's see what. Did I skip one?
It's asking you to make a Venn diagram.
Yeah, it is. So we need to make one. It's just almost 12 o'clock and I'm already tired. Okay, anyways, so what you need to do on your paper draw you a rectangle. Start out with a rectangle. Okay, Ms. Jackson, if you say so. Okay, so I'm going to do it in different colors, okay? So it looks like we have an A, B, and a C, right? We have an A, B, and a C. That's my A. Okay, got it. This is, okay, purple decided not to work today. That's fine, be like that. This is my B, and no, they're supposed to be in the same size, but I'm not, that's the reason I didn't get a degree in art. So even my stick man looks kind of crooked.
You're a math teacher, not an art teacher.
So as long as you know what I'm trying to talk about. If it kind of looks like circles, it probably is a circle with Miss Jackson. It's a C, okay? This is the procedure on how to construct Venn diagrams with 3 sets. So, okay, let's say we need to determine what it is for A, B, and C, okay? You're going to get to a point, and Alex, and it'll ask you to shade stuff, okay? What are we talking about when it comes to those, okay? So what I do is I go ahead and put my numbers in. 2, 3, 4, 5, 6, 7, 8. Okay? So when I am talking about, looking at number 1, determine the elements of A intersect B intersect C. So what is the intersection of A intersect B intersect C? That would be this. The 4, right? That's where all 3 of them overlap. So if I had to shade that in, it would be the 4. It's going to ask you to do that, and you'll be like, what? Okay, so we have to determine what are the elements of A intersect B. So what is A intersect B? What number do you see?
2.
By the way, this is supposed to be a 6. I wiped it off. What do you see?
2.
A intersect B. So actually it is 2 and 4. 2 and 4, right? Yeah, it still includes C too. But it's 2 and 4. So this one right here. 2, 4. You guys know what I mean. So what is B intersect C?
4 and 6.
4 and 6, yes. 4, 6. What is A intersect C?
4 and 5.
4 and 5. Next, we need to determine the elements in each A, B, and C that are not included in the intersection. So, what's not included in the intersection?
1, 3, 7, and 8.
Not included in the intersection.
1, 3, and 7. 8.
1, 3, and 7, and 8. Right?
Right.
One, 3, 7, and 8. Because 8 is not included in any of it. Determine the elements that's in the universe that is not included in, what is OR? What did I say OR was? Union. So I'm asking you is, pretty much I'm asking you what is A, union B, union C, complement?
8.
8. You guys see that? By the way, that's supposed to be the brackets, but I just put squiggles.
Yeah, it works.
Does this make sense? Yeah. Do I need another minute to write this down? Some people just want to, sit back and just watch. And then they go home and go, oh my gosh, what did... So, if you guys want me to, I can put this video in Brightspace so you guys can watch me again. And say, You go home and you're on your own, it's all quiet there, and you'll be like, here I am doing these Venn diagrams, I have no idea what I'm doing. She did so well in class. And your blood pressure goes up, and your face get all red, and you go, ah. So I probably will include it into, because see, I'm teaching a online class, and they don't get to see you guys, so I'm recording for them too. So. Okay, so I'm gonna erase this. Okay, so now we have, they give us this, but we have to, this is where, in Alex, you drop, you drag and drop. So, okay, you take your little mouse.
Yeah.
Okay, so let's go ahead and figure this out. So the first thing we need to do, we need to find out what the intersection of all three. So let's look at all three. What do you see they all three have in common?
4.
A 4. So we'll put a 4 here. So I'm going to like, and a 9, right? So put a little part so it doesn't look like 49. You put it together, it's like 49. Okay. So the next thing we're going to look at, you take them two at a time. Let's take A and B together. So not counting 4 and 9, you can't count it twice. You only count it one time. So what does A and B have in common, not the 4 and 9?
10.
It has 10, right? So you put the 10 here. Now we're going to look at, let's look at B and C. That's this over here. What does B and C have in common, not counting 4 and 9?
Nothing. Looks like.
You don't see anything? Yeah, there's one.
What? The 9 is already included.
Mine's included, that's right. So there's nothing, right? So we don't put anything. Okay, let's look at A and C. That's this space. What do these two have in common, not counting 4 and 9?
1.
1, right? And what?
8.
8. So put it apart so it doesn't look like 18. Okay, next thing is we're going to look at just A. Let's look at A. Tell me what's in A and don't include 1, 4, 8, 9, 10.
12.
12.
You get 12? So you put the 12 here. You just- Let's look at B. Tell me what's in B and don't include 4, 9, 10.
2.
And 3.
2, 5, and
13.
13.
Oh, I didn't.
2, 5, and 13. You see, I got that. Looking at C. Looking at C, tell me what's in C that doesn't include 1, 4, 8, 9.
3 and 11.
3 and 11. Now, what's in the universe and don't include 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13.
6, 14, and 15.
And 7.
Okay, what is it? Say it again.
6,
Uh-huh,
7.
uh-huh.
14,
14
and 15.
and 15. Now, if you want to make sure that you got them all before you click, you know how you want to check your answer, you look at this and you'll say, okay, let me check. So you go through each one like I did. So take it from the, as you notice, you work inside out. Did you notice that?
Yeah.
Yeah. So work within your intersections. Then we take two at a time intersections. Then we take individually A, individually B, individually C. And then we look at all of them and we take out, and then you tell me what's in the universe that's not in all those. Sure. So this is where you drag and drop. And without me showing you this, and you try to do it yourself, you'd be like, I have no idea. Yeah. A lot of people said I kind of made it look fun.
You did.
Yeah. Okay, now, we're gonna shade in the area. Let me erase all my stuff I've got written here. There, that looks better. So I'm gonna erase all these. Well, I'll probably have to draw it again. I'll just use that one. I'll just use that one. So we talked about Venn diagram. Diagrams, and we did a two sets, right? And we did 3 sets. Okay, so let's look at this. We got to shade one of these areas, and you just don't pick one. We have to work on it, okay? So as you see here, this is what they give you. They give you A, B, C, okay? I wrote these in 1, 2, 3, 4, 5, 6, 7, 8. I wrote those numbers in. Because listen, if they typed it in, I'm sure it wouldn't look like that kind of 7, it would just look better. So let's find out what that is. So here I am on my paper, and you go A, intersect B, complement, union C. First of all, what I'm going to work with, my parentheses. Within the parentheses, what I'm going to work with?
Intersect B complement.
Yes, so I'm first going to work with the
A.
complement.
Complement.
Let's work out what this is. What I do is I break it down, okay? Once I show you this, if you guys can do this without him writing that down, that's awesome, but I have to write everything down. I have to figure it out. So looking at this right here, tell me what is in B complement, in order.
2.
Would it be 1?
No, it's not in B. Okay, you cover this up, right?
So it'd be 1,
4, 7, 8.
1, 4,
7.
7, 8. Do you see how it worked? I covered up B. Okay, now we gotta find out what is A intersect B complement. So looking at A and looking at this, what do they have in common?
1, 4.
And a 1 and a 4, right? Now we're gonna take this and union it with C, right?
So it'd be 1, 4.
So,
7.
okay, here we go. We're gonna put what?
1,
1,
4,
4,
7.
5, 6, 7.
5, 6, 7.
Oh,
You see that? Because I took this and I put it in with C. We bring C back in.
oh, so we're bringing 5 and 6 back in.
Yes.
Yeah, you not.
Yeah.
Everything that.
So as you notice, you have to do this first. You do within the parentheses. I found out what the B complement is. Then I found out what this means, right? Then I took this and I took it with the C. Then that's the end. Then so what areas am I going to be shading? I'm going to be shading 1, so I'm going to go here and go. Okay, that's pretty good. 4, 5, 6, and 7. So it asked me to determine the shaded areas. Then you click Submit. Correct. Very good. Fabulous. Have you noticed that on Alex it'll say things like that? Or you're rocking, or,
Don't forget to erase that. Let's put it in the table side.
okay, yeah, I will. But anyways, questions on how I did that. But if you can go from looking at this to this, you guys are better than me. That's all I can say, but I can't. I have to break it down into steps. And if you have to, if this seems confusing, you might want to bring this down here and then run it again. And that's okay. Because you could do this, say you're taking a quiz or a test on Alex, and you showed all your steps, but then you didn't color, let's say you didn't color in that and it said wrong completely. You made a 9 out of 10 on my quiz. But then you show me this, and I'm like, yeah, that's right. So I give you the point. You went from 90 to 100. But then sometimes I agree with that and say, yep, it was wrong. Okay. Okay, now we got to decide. Now we got to, as you see, I tried to draw them the same. We're going to decide if this is equal to this, right? So the way I want to do it is, I'm going to go here. And I want to figure out what they are. So I'm going to buy my paper. And I'm going to write, the first one is going to be what? A union B, union with C complement, right? Put me a line here, and I'm writing down A, union, parentheses, B, intersect C. Okay? I'm going to compare them. That's what I'm going to do. So let's find out, what's the first thing I need to do with this one, right? We need to do the
What's in the
parentheses. So looking at, it doesn't matter which one you look at, okay? What is A, union B? Union B. So what do you have?
1, 2, 3, 4, 5, 6.
1, 2, 4.
Three.
Wait. 1, 2, 3,
4,
4,
5,
5,
and 6.
and 6, right? Then I'm going to find out what is C complement. What is C complement? So that means I cover up C,
1, 2, 3.
1, 2, 3, and
8.
8. 1, 2, 3, and 8. So I'm going to go ahead and bring this down. Sometimes I also mark this. This means this is important. So I'm going to bring it down here, okay? And I write it down again. So in this right here, we have to do the intersection. I mean the union. So let's put these together. So what do you get? 1, 2, 3, 4, 5, 6, 8. Right? Okay, we're done with that side. Now we're going to do this side. I'm so happy I all got done before you guys take your break. So let's do it. So what's the first thing we're going to do?
The parentheses is B intersection of C.
B intersect C. So tell me, looking at this, what is B intersect C?
6.
5 and 6.
4, 5, and 6, right?
I thought 4 intersects with A, but not B.
Well, it does, but we're looking at the intersection of B and C, so it's 4, 5, 6. That's where they overlap each other.
But now it's changed.
4, 5, and 6. Yeah, I know A is included in that, but you're looking at where these two overlap.
Ah.
You see what I'm
Which one's
saying?
in C, that's why.
I don't want you to think about A. Don't even think about it. So where do these overlap?
So why is the 4 included then? That confuses
It's
me.
not touching the B.
Yeah, it ain't even touching.
Oh,
4
that's
is part of A, so would it just be 5 and 6?
It would just be 5 and 6, yeah. You guys are right.
I thought that was confusing for a
See?
second.
No wonder you're confused. Sorry. Miss Jackson was confused.
Wait, what did we?
You guys are getting good when you start correcting Miss Jackson. Okay, so we found out what that is. Now we're going to put, I'm drawing that arrow. So A, union, B, intersect C. So now we're going to put A with it. We're going to put A with the 5, 6.
So it would be 1, 2,
So 1, 2,
3,
3,
4,
4,
5, 6.
5, 6.
Wait.
Right?
Yeah.
1,
3 don't touch
2.
A.
Wait a minute. 3?
3 don't touch A. 3 touches B.
It's not 3.
No.
So it'll be 1, 2, 4, 5, 6. Right?
Right.
Okay, if you're wondering how I got that, this is all of A. Right? Let's cover this up. So we have 1, 2, 5, 4, 5, and then over there we have a 5, 6. Right? So are these the same?
No.
No. So determine, are they equal? The answer is no. Exclamation point.
Or is it equal slash?
So on Alex, it'll say, are they equal? Yes or no. Or they may have you shading in those. And the shading is kind of tricky, so. Okay, I got done with Venn diagrams, and we have time to take a break. Yeah, that was a lot.
My brain
Don't you
is killing
think?
me.
Well, your brain's killing you. I will see you guys at 12:30, come back. Do 30 more minutes. Then you guys can be able to do the other part, the Venn diagrams. On Alex.
And for me, the unions.
Yeah, but I want you to get started on it.
Like, that's what I'm saying, is I'll finally be able to get the unions with no problems.
Well, you should be able to get everything I taught you, so. Let me see, okay, I need to stop my recording. I about forgot. Okay, that concludes our Venn diagrams.